Wind turbines operate in some of the harshest environments, and even a small crack or structural defect can lead to massive failure or costly downtime. In this video, you will see how computer vision can automatically detect cracks, corrosion, and surface deformation with high precision. Here is an example inference from our model, highlighting defects that are invisible to the human eye during routine inspections. Using real-time image analysis, we can monitor turbine blades, towers, and joints without physical contact, enabling faster maintenance decisions, reducing risks for inspection teams, and improving overall energy reliability. Stay with me as we break down how structural health monitoring works and how you can build your own CV pipeline for wind turbine inspection.
Hello everyone, I will show you how you can create a custom YOLO model for detecting damages in wind turbine for structural health monitoring. I have created this notebook which help you with it. So first, in our first step, we have to annotate our data set for this model training. So let's go to labeler for annotation. So in labeler, you have to create a annotation project for polygon annotation with class called damage, and using this you have to annotate your damage wind turbine parts. So like that, using one click you can do that. You have to repeat it for all the part like that. So now similarly you have to do it for all the images, and after that you have to export your annotated data in COCO-JSON format. So let's get to our next step where you have exported your annotation JSON. When an annotation is done, you can export your annotation JSON in COCO-JSON format. Now let's get to our next step. First of all, you have to git clone this library. It helps you to convert your COCO-JSON annotation to YOLO format for fine-tuning YOLO models. I have created this git repo, so you just have to clone it. And using this, you can run a function called COCO-to-YOLO converter, where you just have to provide the annotation JSON part and the image directory part of your dataset. So with this, you just with one click, you can convert your dataset into YOLO format. So I have converted my dataset in YOLO format, and it has an image folder and a label folder. So now next step, we have to clear our GPU memory for fine tuning. Let's start it now. In our next step, we have to start our YOLO segment model training. So you just have to use the YOLO from Ultralytics, and with this you have to just mention the name of YOLO model, which is YOLO 11M segmentation. With this, you have to just start model.train with data equals to your part to your data.yml file, which is created in YOLO dataset folder. So in that you can mention your arguments values such as epochs equals to 300, image size equal to 640, batch equals to -1, and device equal to 0 for GPU. So in workers you can provide 6 or 8 depending on you. This is not a previous model resuming, so you can remove the resume value. Now you just have to run this. After running, you will get a run folder, and here are your weights. So here are your weights. There are two weights, best and last. You can see its performance on your data also. Now in next step, you just have to load this in model part. You have to just mention the part and store it in. Now let's run the inference. Let's create the inference function first. So I have created a simple inference function which is show segmentation. It will show me the model detection segmentation on image, and another function called show segmentation comparison. It will help me to compare the original image and the model detected mask image. So now let's run it. So the model part was not defined. Now you just have to now you just have to run this. As you can see, it is showing us the damages on a wind turbine. So you can also see the comparison, like this is the part where there are damages in wind turbine. This is a drone footage, and here you can say the segmentation overlay of the detection. So it makes us easy to find the damages in the wind turbine from a far away distance. You can take another example image. So this is the same image from some near point, so you can see the same result. Let's take another image. So this is another image, and you can see the damages in wind turbine with clear precision. You can also reduce the confidence to make the model more accepting to these detections which are considered noise here. So with this, you can now train your own YOLO model for detecting damages in wind turbine for structural head monitoring. You can also check our popular YouTube video like how to fine tune YOLO on custom dataset, or can you can build a system using for intrusion detection using YOLO. So I like to see your project in our comment section.
If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description.